Hey, how you going again? We're now looking at RIP version 2. Hopefully we won't be too long in this. I've tried a couple of times to get this up and running, so made a couple of mistakes and packet tracer messed me over, so let's see how this one goes. Okay, our network is the same as what we did for RIP version 1. I'll need to add extra commands in, so I'll do them relatively quickly, but one thing I've got here is some different length subnet masks to class full. I've subnetted 192.168.10.24.0, sorry, /24, which was down here. I've added 2 bits into the subnet mask and made a 4 new networks. This one, the 64, the 128, and the 192 network, which doesn't exist on our little network over here. So we've got classless networks floating around in our LANs and also our WANs. I've taken the 10.0.0.0 network /8 that we had before and divided it into 3 different networks, or a lot more, but anyway, I've got the 3 here. So 10.0.0.0/30, the .4/30, and the .8/30. And the reason for doing all this is RIP version 1 is predominantly class full. It does have a few little quirks about it, which we'll cover one of them. RIP version 2 is classless if we actually configure it correctly. So the bog standard config fails in our network, and we'll show that. We need to add a couple of extra commands to get the thing running. So let's just pop it and put our commands in to get RIP up and running again. So it's like a refresher for RIP version 1. So enable. So conf-t, so router RIP. Now the network commands that we're going to add into this router here is, again, the networks that I'm physically connected to. And I'll show you something about this which gets a bit weird. I'll type the full one in here. How about that? Network. So 192.168.10.0 is our network numbers. So 3 commands have been added into there. While I'm in this config, we'll again put in passive interface out of our gigabit 00, because that's what we did for RIP 1. So we're good with that. Let's just pop right back and let's have a look at the effect. So show running config, and we'll go right to the bottom. Now I've typed in 4 commands, so the passive interface was the 4th, there it is. I typed in 2 network numbers because I've got 2 networks connected to this router, 10.0.0.0 and 10.0.0.8. Let's go back up and have a look at what I added in. There's my network 10.0.0.0, 10.0.0.8, and network 192.168.10.0. And yet the running config up here has said, yep, that's great, thanks for typing 2 commands in, but I'm only going to use 1, thank you very much. Within the config of RIP, it only takes the classful network number. So the classful network for these 2, the actual parent if you like, is 10.0.0.0/8. And that's all it takes. It just says, that's all I need. It'll still advertise both of these networks, so RIP will still run down this path from router 1 to router 3, as well as router 1 to router 2. And it'll actually won't run down here because we put passive interface on, but those 3 networks will be put into RIP and run as routing updates across that network. So that one's up and running. Let's pop onto router 3 and put config into that. And we'll have a look at a subtle variation of what I've just said as well. So conf-t, router RIP, and 10.0.0.0. Now I'm putting that in. Actually, let's do it correctly, or fully correctly. Let's put the actual networks in there, and we'll put in this bottom network as well. So this bottom network here is 192.168.10 10.64 actually is the actual network number, and that's what we advertise on our routers. So 192.168.10.64, and passive interface, write it all out, passive interface, gigabit 00. And let's have a look at the running config now. So show running config. We'll go right down. So there's our router RIP. So just to reiterate, the actual commands I put in was 10.0.04, 10.0.08, and 192.168.10.64, because these are my actual network numbers. But the way that RIP handles it, and it's the only routing protocol that you really want to do this to, is that's the classful network. Actually, ERGRP does the same, but I tend to avoid it. And this is the classful network for 192.168.10.0. So the parent 192.168.10.0 is the parent of 192.168.10.64 down the bottom there. So let's pop into router 2 and add commands in that. Whoops, I'm typing stuff and nothing there. So enable, so config mode, router RIP, and let's go passive interface first for gigabit 00, and we'll also do it for gigabit 1 because that goes out to our internet out there and we don't want that to go through, so there's a subtle variation on router 2 up there. Now the network command I type in here is just that one, and the network command 192.168.10.0 is actually correct for the other one. Now, so far so good for router 2. The one thing with router 2 that we do have, if I do show run, I think I still have my gateway of last resort on this router. There's our commands that we've just typed in. So what I need to do is send my default route to router 1 and router 3 via RIP. And I do that with default information originate. So they will know where their routes are going. Okay, so I've put RIP in. It does take a little while to converge, so I'll just fast forward time a bit. And let's have a look at router 1, because it seems to be the one we're always looking at, and see what its routing table looks like. So if I show IP route, lucky I can type today. So there's our gateway of last resort has been set, and there you can see it's coming in via RIP, so good. Now there's an error in here, and there's also something that is a bit quirky. So when we did RIP version 1 in the last video, we had an 11.000/8 network over here. And on router 1, we looked at it and it said, yep, we load balanced, and this is exactly what we've got again, except for one quirky little thing. We're on the 10.0.0.4 network, and it's given a /30 subnet mask. But how did it do it? So if I go and debug IP RIP, let's look at what information is actually coming into this router to give us this information. So we might just fast forward time there as well, get some debugging stuff happening, and undebug all. Always a good idea to debug, just to have a look at what your protocols are doing. Ooh, we went a long way down, didn't we? Okay, so we've received, so this is where we put debug IP RIP. We've received a version 1 update from 10.0.0.9, which is router 3. And it said this is how to find the gateway of last resort. You can find it in 2 hops. So this update is not used because router 1 can find it in 1 hop via router 2. Actually, there it is there. So that's a better one. But let's have a look at this. It says 10.0.0.4 is found in 1 hop, which is novel. It's not giving us the actual classful boundary. So it's actually giving us the full network number, but it's not giving us the subnet mask in version 1. Version 2, as we see, will give us the subnet mask, but this one is not. So the question is, where does it find, or how does it know to put the /30 in there? It knows because there's a /30 on this directly connected one, and it assumes that everything across the board that starts with a 10 network is going to have a /30 on it. So RIP version 1 is not as dumb as it is made out to be. So it has sent us the network number, and it said, oh great, we can do that. However, 192.168.10.0 is the network that router 3 is advertising as its network, found in one hop. This is classful at the moment, or it's advertised as that network number, not the .64, even though this one is .4. Go figure. So our router looks at it and goes, well, yeah, I've got a 192.168.10.0, and I can match 26 bits out of this, so I won't show that network in version 1. I won't show you as an option, because I've got to actually better match in my routing table at the moment, because I've got it directly connected as 192.168.10.0. It's better. I can match more bits, and I won't show you. Now, we've received a similar network from router 2, and again, it's still matching it, but I've got a match there, and I'm happy. Okay, so show IP route. Let's just see, nothing's changed. Good. Let's have a look at router 2. Let's just go enable class. Show IP route, and we can see there again we are load balancing the serial, and it's come up with a /30, which is awesome, but nowhere in there do we have 192.168.10.0, which is not the /28. We've got that one, but that's just saying that's the parent, and these are the subnets of that, because it's variably subnetted. That's just the way it shows it in the routing table. So what we need to do is we want to get a /26 on router 2 for this network, and we want to get the this .64 network done here on router 2 and router 1 as well. So what I've said is version 2 is where we need to be. So let's go into that. So conft router RIP. Now let's put in version 2 here. So if you put a question mark in there, we can see that we have the option to put version in there. So let's go version and version 1 or 2. So by default, RIP runs version 1. I'll put version 2 onto router 1. Now it's great running version 2 on router 1, but we also actually need to run it on router 2 and router 3. So let's go in and do that as well. And we'll put version 2 onto router 2, and we'll put version 2, if I could type would be happier. Going already. So conft router RIP and version 2 on router 3. So whichever version we're running across the board, it has to run on all the routers that need to be involved. Let's go back to router 1 and let's have a look at what's the outcome of this. So let's debug IP RIP for a start, just to see what version 2 has done for us. So let's get another couple running. So we've received. Let's get a sending one as well. We might fast forward time there and pop back in if we send stuff. Yep, good. Let's undebug all. I'll just use the up arrow because I'm sure I had it. Yep, good. So let's go back up to the top of this. There's a fair bit in there. So debug IP RIP. Now we've received a version 2. Here's version 2 update from this address, and there's something unique that's also happened. When we send it, send a version 2 update, and now we're sending it to 224009. It's actually an IP address. See if we can find the previous one. Yep, we've just got it on the top there. Good. When we sent version 1 updates, I've just scrolled up in my CLI here. We've sent a version 1 update, and we sent it to the broadcast address 225.225.225.225. 225. Wow, 255.255.255.255. Dyslexia is killing me. Is it Alzheimer's? One of the two. Okay, so version 1 does it to 255.255.255. Version 2 now sends it to not the broadcast of 255.255.255.255, but to the multicast of 224, which, for those of you who know, it's a D class address, 224009, which is RIP version 2's IP address. It will send and receive updates on that address. So that's one thing that version 2 has done for us. The other thing it's done is down in here. We've now got /30/24. We're actually sending the subnet mask. Sending it there, receiving it there. If you looked at version 1 updates, we're just sending the network number. So, good. We've got more information being sent out. Now, that's good. You may see the error in there. It's not actually an error, it's just something that's going through. 192.168.10.0/24 is being received from 2 hops. There's 1 hop. 192.168.10.0/24 is coming in from router 1, from router 2. No, from router 3, sorry. 10.0.0.9 it's coming from. And it's saying this network, 192.168.10.64, is actually being sent with 24 bits in the subnet mask and the .0. So we need to change that. But let's just quickly have a look at our routing table now. So show IP route. And we've actually got a new entry in here as well. So previously we had the load balancing to 10.0.0.4. And now RIP is giving us 2 paths to 192.168.10.0/24. It's saying you can go via router 3, or you can go via router 2 to get to the same network. But if you look at our system here, they're not the same network, they're actually separate networks. 192.168.10.64/26 is the orange guy, and 192.168.10.128 is the blue network. So RIP version 2 is good because it's giving us a bit more information, but this is a problem. If we've got discontiguous networks, which we have here, then what router 1 should do is load balance between these two. It's always dangerous with packet tracer doing this, so we'll see if it actually load balances. So if I ping 192.168.10.130, which should be that PC there. Yep, it is according to that. Let's see if it works. I haven't tested this yet. One ping should go through and the other should fail. And this one says it's fully successful, so I'm not too sure how it's actually getting there, because one of the pings should go up there and the other one should go down this path. Truly, I think it's a packet tracer glitch. Let's try it again. We're in simulation mode. And let's capture forward, so it's just sending it up there, to there, to there. And it's coming back. Come on, hurry up. It's coming straight back down the path. Oh, it is load balancing. And he's sending it up there. So why is router 3 sending it up there? So let's have show IP route there. That's got an error. For some reason it says that it's only up there. Router 3 should load balance. It really should. Anyway, if you build this physically, or maybe it's just taking its time to converge properly, that should, every second ping should die. So it's a bit messy. You really want your packets to go the correct path. So let's solve that. We don't want to load balancers, and we don't want 24 bits in our subnet mask, we actually want 26. We've said version 2 will update, but it hasn't, and the reason for it is, let's go to conft, write a RIP, put a question mark on in our RIP, and it's this geezer here, auto summary. We don't want the default, which is to auto summarize at the classful boundary. We don't want to have that summary address propagated out, so we need to type in no, negate the default, auto summary. And again, you need to do this on all your routers. So we'll go into router 2, and say no auto summary on router 2, and we'll go into router 3, router RIP, and no auto summary on there. And what we should end up with is a better routing table. Now this is a cute one, this is a good one. We've actually caught it just at the right time here. RIP is relatively slow at converging. Now, by typing these commands in, we've actually triggered an event which should update the system. And you can see the updates have come through here. So RIP has given us 192.168.10.64 via 10.9. So from 3, it's telling us I can match 26 bits now, and I can match the first 26 bits out of 192.168.10.64. And from router 2, we're also getting 192.168.10.128. So that's great. But we've also got this route sitting in our routing table. 192.168.10.0/24, and it's saying there's 2 hops to get to this network. What it's implying is that we've got to go through router 2 to get to a network that's living on router 3, which is 24 bits long, is what we're matching, and it starts with 192.168.10.0. Now we know that there is no network in here that has done that. But because these routers are relatively slow to converge, and they should have converged by now with me talking, that will still exist in the routing table. It's the way that RIP runs. So if a network dies, RIP will hang on to this network for a short bit of time, so it'll receive an update and go, oh, I didn't receive an update for 192.168.10.0/24. I'll hold on to it for a bit, because I'm assuming that network is going to come back. Eventually that hold time will run out, and then we will assume that if the updates don't come through for the network, then we will assume that that network is dead or been taken out, and we'll flush it from our routing table. And it's still in there. In fact, we've got 2 networks now, so it's kind of cute. So let's fast forward a whole whack of time and see if we can actually solve it for us. So show IP route, and this is now a fully converged network. You can see this one suddenly decided to add a second path in there as well. 10 with 2 hops again, so kind of cute, kind of messy, and that's because RIP is really quite a clunky protocol. It's slow to converge, slow to solve problems. This is correct if you look at this. So we've got it directly connected, 192.168.10.0 with 26 bits in the subnet mask. We've got a .64 network with 26 bits and a 128 network with 26 bits in the subnet mask as well. Both 1 hop away. And that's correct. We know it's correct because we can look at that network and see it. Let's have a look at router 2. Show IP route. And is it correct? Yes, it is. That's got the extra network that's connected out there, so that's directly connected. This network is not seen in router 1 and router 2 because we're not advertising that network. That 220.20.0 network is not being advertised in RIP. Let's have a look at our running config. We're not advertising it because it's our internet. We do not advertise that. We put in a gateway of last resort with that static route, and then we put in our default information, originate. So we do not advertise that network out. So that's fully converged, and let's have a look. Ooh, let's go. Show IP route, and that's fully converged as well. So good. That network is running RIP version 2. It supports variable length subnet masks. All these links all over the place. 30 bits here, 24 bits there. It's not classful, but as we saw with our running config, this is back to router 2 up here. Some classful stuff is still used, so it's not completely gone. But yep, nice. Don't forget your auto summary. Don't forget your version 2. So those are the only two commands we've typed in over version 1 to enable variable length subnet masks on a discontiguous network, actually, to run happily across our network. Done. Thank you very much. See you later.